Good morning. My name is Janie Montblanc, and on behalf of the Great Basin Fire Science Exchange team and our partners, I would like to welcome you to this webinar titled Landscape Science Solutions for Resource Managers, presented by Jerry Tagestad from the Pacific Northwest National Laboratory in Richland, Washington. Before I introduce our speaker, I want to let you know that you may ask questions of the speaker or me at any time during the webinar by typing them into the questions pane of your control panel at the top right of your screen. I will keep questions for Jerry in the queue and field them after the presentation. I also want to let you know that whatever you do in your control panel does not affect the webinar presentation, so you're welcome to type a test message to me or test your audio at any time during the webinar. Now I would like to introduce our presenter. Mr. Jerry Tagestad is a staff scientist in the ecology group at the Pacific Northwest National Laboratory in Richland, Washington, and an adjunct professor at Washington State University. His scientific expertise is focused on providing spatial technology solutions to diverse projects with specific skills such as image feature extraction, GIS automation, remote sensing vegetation classification, hyperspectral data analysis, and field data collection. His expertise in landscape ecology solutions are currently being applied on projects with the U.S. Department of Defense, Homeland Security, U.S. Fish and Wildlife Service, and the Department of Energy. Welcome, Jerry, and thank you for being here today.
Well, thank you.
Okay, I'm making you the presenter.
Okay. I'm going to show main monitor 1 and
Yep, I see it.
start the presentation. Okay, great.
Great.
Well, thank you once again for the invite. Thanks to Mike Pellant for suggesting this, and Janine for inviting me and setting it up. I am Jerry Tagestad. I'm in my office with Janelle Downs, who is a colleague that's just adjacent to me, and is I'm the geospatial type in the ecology group, or one of them. Janelle is an arid lands ecologist that has a lot of experience as well with remote sensing, so I wanted to invite her in on this. I also wanted to note that most of the topics today will cover tools that were developed on a project that was funded by CERDIP, which is, I'll describe a little later, but we collaborated with USGS, Matt Brooks, Rob Klinger, Randy McKinley from USGS especially. So I want to give those guys credit for keeping our science moving forward. Slide 2, I hope everyone is following along in real time. If there's a big lag, let Janine know, and she can let me know.
It seems fine.
Okay, good. Just one quick background on who we are. Pacific Northwest National Lab is one of the Department of Energy complex of labs like Oak Ridge or Argonne or Idaho National Lab. We're located in eastern Washington on the dry side of the mountains, and we do all sorts of contract research. So we work, well, we're a DOE lab, but we don't really work. We are managed by Battelle, and we do research with all sorts of other entities through interagency agreements, especially with federal entities. And it's a fair-sized operation. We have almost 2,000 scientists, at least as of FY12. Well, the next slide kind of describes the philosophy that we've been taking in terms of tools for landscape managers. The title, Information is the Key, is intentional. There are cases where you certainly don't have enough data, but as computers have become ubiquitous, the amount of data available to people is often very voluminous, and what is often lacking is information. So we've been concentrating on these two pieces of the pyramid, the analytics to help make sense of the data and the tools to deliver that information to the user that sits at top. So the folks on the line, I think many of them are at the top of the pyramid here. They're the ones that may need to make a decision, and they need access to that, that synthesized information that's based on good data. So an example of one of the tools that we've developed and are continuing to develop is the ability to assess some sort of relative productivity. And I put in parentheses MODIS sensor. We're relying on the MODIS satellite sensor for this particular example. And the challenge being, how do you understand what's going on in these far-flung regions? How do you monitor what's going on? Our solution, in the case of the project that we'll talk about more in detail near the end, and it was based on some work that we started, probably 10 years ago with NASA, when MODIS was relatively new, is to utilize that frequent remote measurement to be able to get a touch or a vision of the productivity. And I put in parentheses there NDVI, the Normalized Difference Vegetation Index, which is essentially a measure of greenness. How green are things right now, and how have they progressed throughout the year? To kind of give an example how this tool may work, and I'll show a live demonstration at the end where we actually do this. On the right, we see a map of some region of, in this case, it's the Mojave, and we have our fire risk map on top. And I want to call your attention to the pixel on the left. By clicking on that, I can get a measure of what's happening this year. In this example, imagine I'm sitting in my office in May or June 2014. I can see what it was and how it's developed throughout the year, and how that compares to the long-term median for that particular site, and what it was like last week. So this data comes down on a very rapid and dynamic basis, and it's not a tool that tells you the answer, but it is a tool that allows you to get a view of what's happening in an area, and you can apply your understanding and expertise to divine some meaning from that. If you look at a different area in your region, you might see quite a different signature. You see that to the east of the site that I selected previously, by about 20 miles east or so, was quite a bit different. And you see that the 2014 line in the graph, which is relating to the NDVI in the y-axis and the time in the x-axis, is well below the median at the time when you normally see a peak, suggesting in that site lower productivity. So the take-home message is that it's possible to have a tool that can provide understanding of current conditions across the entire western United States, and be able to compare that to the relative historic condition for that site, as well as landscape conditions. And what I'm not showing here are all 15 years of MODIS data for that site, but that's something that we'll look at in the demonstration. And the impact, I think I mentioned, being able to understand the relative conditions out there for a very recent period and compare it to other periods of record or other locations. Another analysis that we have developed over the years and are currently testing application for a slightly different use is detecting landscape anomalies through remote sensing and geospatial data fusion. And the idea behind that is that detecting early some sort of potential problems or monitoring for tipping points, state changes that may be going to a negative, or even in a restoration application, you may be able to check whether something is is what's the term I'm looking for, is improving based on the restoration. The way this works is to take these high-flying remote sensing data. In this case, it's from the Landsat sensor, but it can be from any sort of suite of sensors, and put the pixel into some sort of context by stratifying the landscape in some fashion. In this example, we use the ecological ecological site descriptions from the soils database, and looked at the distribution of pixel values within ecological sites. And so the graphic on the right is showing, that's just southeast of Boise, and that yellow inset shows where we identified some very detailed anomalous regions, detailed in terms of spatially detailed at a very fine scale. And via field visits, we see that indeed that is a site that is, in this case, very low productivity and of management concern, potential management concern. If we take that apart a little further, I'm showing for a region of the Snake River Plain the May NDVI histogram. So once again, now the x-axis is the NDVI value increasing to the right, and the histogram is the count in the y-axis. And we see a fairly normal distribution, but we asked ourselves, and the way we implemented this is starting to look at the pixels that were several standard deviations from what you might suggest. If we isolate pixels in that little bouncy orange area that just flew in there, and map those back to that particular ecological site, we found that they were somewhat surprisingly compact areas. They weren't scattered all around the ecological site that when we initially talked about doing this, I thought maybe it would just be the noise that shows up. Well, it's not noise at all. It turns out that these areas were, in the May NDVI, highly productive, well beyond what you would expect for the rest of the ecological site, and they were covered with annuals. So by combining, let me see if I got my animation. Yeah, by combining in this case, the ecological site, but it could be other sorts of stratification. We're exploring using the same approach for updating vegetation maps and using existing vegetation as a stratification. By combining these things, in this case, the ecological site conceptual models with the remote sensing, we put the pixel into context and identify areas that may be relevant to landscape management decisions. And the idea that you may be able to really improve and optimize some field resources and save yourself some energy. Tool number 3 that we'll probably spend the most time speaking about, and what I was talking with Mike Pellant about at a meeting in Boise when he suggested we do this webinar, is also based on our work with the USGS collaborators in the Mojave ecoregion. That's what's being shown in the panel on the right. CERTIP is Department of Defense, EPA, and Department of Energy program, largely focused on environmental concerns within the DoD-managed lands. And we've just completed a 4-year project with CERTIP. And one of the outcomes of the project, there were many, and we can talk about if anyone else is interested in fire in the Mojave. We have a lot of science that's been recently completed. But one of the outcomes was the development of a pre-season fire risk model. So we're modeling fire risk early in the season, and the idea behind that is can you get a picture early on in the planning horizon that allows you to stage resources or give you some expectation of what the fire season is going to be like. And by early on, in the case of the Mojave, we're basing our information on, well, we're developing the maps in the May time frame. By developing the maps, I mean applying the model, and there are inputs that we'll talk about that are critical to it, but we're relying heavily on the satellite greenness and its response based on the wintertime precipitation. So we're looking at several dynamic variables as well as static variables. Let's talk about those. But the idea behind it is to give timely and location-specific assessment of fire risk for the upcoming season. The conceptual model for this looks like what's up on screen. Basically, a simplified version of the model. It's risk times the probability of ignition times the probability of fire or burning. And we looked at many different variables. For the last, we used a 30-year fire history, fire polygons, and a fire starts database from about 26 years of fire starts that were points that had the cause of the ignition, to assess the relationship between different landscape variables. And we ended up with, maybe not surprisingly, the distance to road and the lightning density as being the most closely correlated with the fire occurrence and size. So that's the left side of the model. The right side of the model is the probability of burning if you do get ignition, so the fire. And we have vegetation type available as geospatial layers, land fire or whatever source of vegetation you use. But in addition to that, we wanted to get a measure of the fuel load. And I want to define those terms underneath there. That we have delta WPPT, which is the difference in the current season winter precipitation to the long-term median winter precipitation for that site. And the delta NDVI is much the same flavor. It's the difference in the peak for that current season and between that and the long-term median peak for that site. So you folks, everyone in the Great Basin knows, you get a really wet winter, you have a much higher likelihood of having a big fire season. You get a dry winter, things are more calm. The Mojave responds the same way. Temporarily, maybe a little earlier, because you get peaks in March and in April rather than some of the peaks that you see in the Great Basin. What else do I want to add on this? We did look at precipitation over an annual period, or the springtime precipitation, and definitely the winter period, in this case from October through March. That winter period precipitation for the Mojave was the most critical in lending to the development of fuels that will carry fire. Yes, even in the Mojave. And to show that conceptual model in a much more colorful way, this is the graphic that you might have seen on the intro to the webinar, is that ignition, fuel, variables. The ignition is the distribution of historic lightning density. So we looked at lightning strikes from 1980 all the way to 2010 and calculated a per kilometer density, and that's what that map represents, the heat map there. And distance to roads, we looked at many different ways, but there's, according to the fire starts database, there's definitely the natural and human-caused fires have a different distribution as to their relationship to roads. There's a lot more human-caused fires closer to roads, surprisingly. Not surprisingly at all, as it turns out. And the delta NDVI map, that's for a particular year, a particular growing season, and the delta precip shows the difference from the long-term median for that same growing season. So you put all these together in the model, and you end up with a map like below that shows you a spatial distribution of the preseason fire risk. And once again, you're doing this in well before the season begins, and the development of the fire conditions have really started. So well before things are drying out. Oh, I didn't clean up this slide, so my apologies, but I wanted to show, I'll just click through to the end, at least one geeky slide that shows on the y-axis are the number of fires. And on the x-axis is the delta NDVI for, in the small upper left graph is for year I, so that particular year of concern. If you're doing this next year, it'd be the delta NDVI for 2015. And the panel to the right is the delta NDVI for that particular year plus the previous year, because as you know, you get some sort of carryover if you have a wet year 2 years ago. It may give you some fuel carryover. And we definitely saw a distinct pattern in terms of the number of fires that are occurring when you get a year that is well over the long-term median, which is represented by 0 here. And the same type of data for the winter precip responded in a much similar fashion. It's a different scale of measurement. We use the PRISM precipitation data, which is either 1 or 4 kilometer pixels, depending on what period of record you get. So you don't have the spatial precision in these data, but we see a similar pattern in that when you get a year that is well above, that has a lot of more rain than the median, represented by the long-term median, represented by 0 in this case. And the long-term median in this case was 30 years of rainfall data. And you see many more fires occurring when you have that condition. And I just wanted to put at least one word slide up there that shows the logistic regression model, kind of how we went about it, and what we did in terms of cross-validation. And I'll call your attention to the accuracy below. So we got an overall accuracy of 78%-ish, and false positive were 6.3%. That's where false positives are where you predicted a very high risk area and no fires occurred. False negatives are where fires occurred and you didn't predict a very high risk area. So we broke down the errors in that. We're quite pleased with the results of the model across this 13 million hectare region. So we developed the model, built it, and then we went back to the data and we ran it just like we would in a preseason fashion for all the years in the historic record, because we had all the fires, all the acreages of hectares burned for every year. So I'm going to kind of step through an animation of what the map looks like each year. And down in the lower right, we'll also have that being animated in terms of the number of fires that occurred for that particular year. So 2001 and 2002 were really quiet years. Mojave doesn't get as many fires in general as you see in the Great Basin. You see the pattern or the distribution of areas that are low and moderate changing between the years, and that's driven largely by the precipitation patterns of that particular year. In the short term, longer term, it might be landscape changes. 2005 was an enormous year in terms of rainfall and a big spike in the number of fires and acreage burned, and a big difference in that map between the 2005 years and others in the Mojave. 2006, 2007, we walked through and ran it on all of the years in the MODIS record up to, and then we finished this work in May of this year. So we ran it in May of this year for the 2014 fire season, which our model indicated for the Mojave was not too much going on. Very few areas are elevated above the low risk, and the initial data from the burns in the Mojave indicated there were none that were greater than 1,000 acres. So we felt pretty good about our ability to predict the distribution of fires. I'm going to now switch from the sort of static view of the PowerPoint and introduce our prototype portal that we built for the Mojave to dynamically deliver some of the information in here. And I guess we'll take questions after that. How are we doing on time here? Oh, good. Only 25 minutes. So we should be seeing on screen now a map of the Mojave. It's showing the 2014 fire risk map in the background. So we've got some basic geospatial functions in here in terms of background imagery, roads, the topography. Oh, we want to show off the overlay here. And you can see that in the 2014 fire risk map, we see some variation across the landscape. And what I wanted to demonstrate is that we have not only the synthesized product of the fire risk, but we have what's really driving the fire risk in the background. So I just opened up another window to the right. Let me get rid of a few of these years so to make it a little bit easier to understand and be more similar to what we were looking at in the 2013. I don't know why it's not shutting off. That's okay. So in the panel to the right is a dynamic panel that says, okay, for that pixel I just clicked on, the long-term median for that site is the peak generally occurs third week of March, and it's around this value. We see in 2014 for that particular site, which shows us being an elevated fire risk, that the 2014 response is much larger than the long-term median, well above. Now, down here in the gray and lighter green lines are the 2013 and 2012 response for that site. Very, very low, and we can add any year of concern that we want into this into the graph and start comparing this site to what we might expect based on the long-term. Long-term in this case is the entire record of the MODIS sensor, which was launched in 1999, so basically 2000 on, and how we're comparing this particular growing season, and this was launched in early May, so this last point is it was launched in early June, I should say. So, you know, we have a 1 week lag time on measurements available to us. So we can say, well, what was it like 10 years ago? What was it like on average? And what was it like last week? Is all available in here. And another one of the functionalities that I think is really exciting is being able to compare that to another site that you're maybe familiar with. You can compare it to another point in time you're familiar with. So I just clicked on another site that gives a much different picture in terms of the greenness development for this particular year. And the long term is relatively similar, although it's not a very productive site by the looks of it. Let me select another one that I know is, yeah. So there's another example of, okay, the long-term median. So this is for the site just east of the Mojave Preserve. The long-term median is relatively low, but this year it's well below the long-term median, and last year was the same, and any one of these years should show up automatically. And we can compare it to 2005, which was or 2009 in this case, a year with much better precipitation. So you get a sense of the patterns of development of vegetation and its relative productivity, and you can compare between sites of interest and concern. So you have the map that you can glance at and gives the big picture view, and then there's a lot of more nuanced information that that's driving the development of the map that's available to an informed user for them to make an assessment of what's happening this year compared to all these other periods. What am I leaving out, Janelle? Any other? Oh, yeah. So the data in not only in the graphs, but the data in the map would be downloadable, and you can bring it into your GIS for your own analyses or into a report if you wanted to just take the graphic into the report. So I think I was able to get through that, Janae, within 30 minutes now. So thank you, everyone, for the attention, and we are more than willing to address questions. If they're more along the fire ecology side of things, I'll have Janelle answer them. If they're related to pixels, I'll answer.
All right, great. Thanks, Jerry. So, yeah, if you have questions, please type them in at this time, and I'll field them to Jerry. So the first couple of questions are from Kristen Allison. Her first question is in regards to the previous series of slides with the maps of fire risk and then the actual acreages that burned. And her question is,
yes.
were all the fires over the whole time? It appears that China Lake was on every year.
Let me go back through this slide because there's one thing that, and Janelle said, make sure you point out this, and I never pointed it out. Any black areas in the map are not modeled areas. We're not showing the fire boundaries on the map. So there's potential for confusion there, but I'm looking at how China Lake risk varies throughout the year, and the spatial patterns of it vary greatly. So, sorry, was that a confusing, because I left out that bit of information about we're not showing fires, we're showing...
She said that's what she wanted.
Black areas are not modeled.
Yeah, she said that's what she wanted to know, so she was thinking those were fires.
Sorry, I apologize for that.
Okay, thanks. And the next question, will this be available through IFTDIS?
Well, I don't know what IFTDIS is. The plan is to transition what we have now for the Mojave to the California Fire Sciences site, and that's easy to do. Right now, our prototype portal is very portable. If we were to scale this up to a larger region, or if we get additional funding within the Mojave region, we would maybe change the way things are doing. So you'll have to describe to me what if this is, but that's the plan for the current incarnation of our prototype portal.
Yeah, IFTDIS is the Interagency Fuel Treatment Decision Support System, if I'm remembering correctly, and as Kristen Allison mentioned, it's software that integrates components for fuel specialists to share at a landscape scale, and I believe it's developed by the Joint Fire Science Program and others. So yeah, it'd be interesting to see if it could be combined.
The concept.
Yeah.
Fits.
Okay, let's see. I believe those are all the questions. So I have a question. So is this being developed for the Great Basin area? What can you look at right now?
Good question. Right now, the Department of Defense the CERTA program funded us for the science focused on the Mojave, and that's where it was built and developed.
Okay.
That project is just recently over, and that's where where it's currently available for. We have been in discussions with folks at the DOI and BLM about scaling this out to the Great Basin. It would be, the Mojave is similar. It's not, of course, exactly the same, so there'd be a little bit of a development time, but we feel the model is it's reasonable to expect that you could step it out to the Great Basin with a moderate amount of effort and have this available. Right now, it is not. Mojave ecoregion is where we developed it.
Okay.
But we're actively pursuing.
Yeah. So, and this type of approach is most applicable for rangelands, and I think particularly shrub steppe ecosystems would be amenable to being quantified in this manner. When you get up in forested systems, the signatures and signals that you get from the Delta NDVI are probably not going to be directly as meaningful as they are for these more arid systems.
Gotcha.
So there would be some development that would need to be done and to get the model to operate correctly there.
So now we need to find you some funding.
Oh, I'm glad you said it.
We're really quite excited about this, and a lot of people get excited about the ability to really compare those signatures for particular sites through years, whether it's for looking at grazing management or for whether it's looking at how effective your restoration treatment was at a particular area. You can say something about the condition of a particular land area or region and how it compares both spatially and through time. And I think that's useful information.
Yeah, definitely.
And on that front, we are meeting with Jim Douglas and just confirmed at the DOI offices in D.C. In March, and plan to brief him, a fairly high-level briefing on what this could bring, just for fire planning and fire science. So there's hope, but we're definitely pursuing the development of this for the entire West because it is a viable solution.
Yeah, great. Okay, we have a couple more questions that came in. Will you be producing a paper on this?
Yes.
Yes.
That is part of
In the works.
We just completed the report for CERTA, and which is multifaceted, but there will be a separate paper just related to this effort on the model.
Yeah.
Wonderful. So maybe when that's completed, I can get that for you and distribute it to our listserv or post it on the website or something.
Absolutely.
Great. And last question, it looks like Greg Schenk asks, how are you obtaining your precipitation data? RAWS stations?
Good question. We are using the PRISM precipitation data, so it's already a spatial data set. They've interpolated over 3 dimensions. I think most people are familiar with PRISM, and I don't know if they utilize all the RAWS data or not. But that's the data we're relying on.
Yeah, and it is an interpolation based on as many precipitation stations as they include in the model. It's a PRISM model developed by Oregon State University, and they basically produce a spatial model of the weekly precipitation, which is fairly readily available, and not in real time, but in near real time, within a few weeks.
Yeah, it's frequently updated.
Yeah. So that gives us a really useful set of information that's already out there to pull into the model.
Great. All right. Well, thank you. Oh, wait, another question came in. Gabriella Collin asks, I've tried to create a similar model for our basins, but feel that NDVI with 30-meter resolution is too coarse to apply effectively. Do you have any insight on how to reconcile the coarseness that relying on NDVI causes?
Well, the NDVI data at 30 meters would be coming from the Landsat sensor And it has a different problem, in my opinion, in that it's temporally coarse. You may only get 4 or 5 measurements per year, especially in the winter season when you really want to see how things are developing in the spring when you have lots of clouds. We are relying on MODIS data, so in a way, we're not going to please you by saying that we're making each of these risk assessments at a 250 meter pixel. But the objective of the pre-season fire risk mapping is to provide from a regional basis the distribution of the variability of the upcoming risk. So we feel that 250 meters is more than, it is adequate for that. Now for other applications, and I think what you're referring to, that 250 meter or even 30 meter can be too coarse. But for what we were intending, I think it's a reasonable scale.
Okay, thank you. That looks like the last question. We would greatly appreciate it if attendees would take our 3-question survey of this webinar that will appear after the webinar has ended. And I wanted to let you know that a recording of this webinar will be sent to you automatically through the GoToWebinar system tomorrow, and we will also post it on our website within the next couple of weeks. If you have more questions regarding this webinar or have requests for future webinars, please email or call me at any time. Yeah, and thank you to both the presenters today. I really appreciate it, and thank you everyone for participating today.
We have one final thing that Janelle just asked about.
Okay.
I'll give my contact information on screen, so that'll be in the recording.
Oh, great. Thank you.
I failed to add that slide at the end.
That's okay. We got time. We'll wait.
Okay. Okay, let's flash that up on there so at least it occurs.
Wonderful. Thanks, Jerry, and thanks, Janelle, too.
Thank you, and thanks for the invite. And any other questions or comments or concerns or discussions, I'm glad to have them. Just people can contact me or us directly.
Great. Thanks so much. All right, have a good day.
Thank you.
All right, bye.